Imagine for a second that you just plug your phone into the wall, right?
Right.
And instead of waiting, I don't know, an hour for that little battery icon to slowly tick up to 100%, it turns green in a fraction of a millisecond.
Just instantly.
Yeah, just a single invisible flash of energy and your phone is completely full.
It honestly sounds like a party trick.
Hmm.
Or, magic.
Right.
But I think what is truly bizarre here is that if you took that exact same underlying battery technology and you scaled it up to the size of an entire electric car,
Oh, wow, okay.
that car wouldn't take longer to charge. It would actually charge faster than the phone.
Which, I mean, that feels like it completely shatters our basic understanding of how power even works.
Totally.
It's physics behaving like science fiction.
Yeah.
And, well, that brings us to the mission for today's deep dive.
Exactly.
We are looking at a stack of incredibly fresh source material today. We're pulling dispatches from the middle of May 2026.
Very recent stuff.
Yeah, we've got reports from Science Daily, updates straight from the science journals, and some global breakthrough summaries.
And we are focusing specifically on this massive convergence of two fields that are currently experiencing just breathtaking leaps forward.
Right.
Quantum technology and space exploration. We really want to see how these breakthroughs are moving out of the lab and, into the real world.
Because the goal here is to filter out the dense academic jargon, to figure out exactly how these mind-bending discoveries are going to change your daily life in the coming decades.
Absolutely.
Because by the end of this deep dive, you're going to understand how that electric car might charge in a split second.
Yeah.
And how an AI-driven spacecraft might already be looking at a curated shortlist for, well, Earth 2.0.
It is a phenomenal time to be paying attention to this stuff.
For sure.
Because to push into these next eras, whether that means traveling farther into deep space or running the incredibly complex next-generation internet networks we're going to talk about, we first need an entirely new way to handle power.
Right, because our current foundation is, it's fundamentally flawed for the future.
Yeah, standard lithium-ion chemistry has taken us really far, but it has a hard physical limit.
We are hitting a wall.
We really are.
This is Better Side of the World, where we find good news from around the world. Introducing your favorite AI hosts, Delta and Tide.
Which brings us to the first massive breakthrough in our sources today, the quantum battery.
Yes.
An international team led by Australia's CSIRO, the University of Melbourne, and RMIT University. They built and successfully tested the world's first working proof of concept.
And we have to be super clear here. This isn't just like a chemical tweak to make a battery 5% more efficient.
No, not at all.
This device operates entirely on the strange rules of quantum physics. It utilizes a phenomenon known as superabsorption.
Okay, let's unpack this. Because normal chemical batteries, like the ones sitting in our laptops right now, they rely on a chemical reaction that has to physically spread through the material inside the casing.
Right, it's a physical process.
Yeah, think of a normal battery like a single person filling up a swimming pool with a bucket.
I like that.
The bigger the pool you build, the longer it takes that person to fill it.
That is the perfect way to visualize standard chemistry. It is strictly linear.
But according to the sources, quantum superabsorption basically bypasses that completely.
Yes, it does.
Instead of one person with a bucket, quantum superabsorption is like suddenly having 1 million people with buckets, right?
Yeah.
All surrounding the entire edge of the pool, acting collectively in exact synchronization.
That's a great analogy.
So adding more volume to the battery just means adding more people with buckets, meaning the massive pool fills up just as instantly as a tiny puddle.
You've hit on the core mechanism there.
Okay.
Because in the quantum realm, the molecules in this battery are not waiting in line to react.
They're all going at once.
Exactly. They enter a state of quantum superposition where they act collectively as a single entity rather than individually.
Wow.
So when you add more molecules, meaning you make the physical battery larger, they essentially cooperate to pull in photonic light energy more efficiently.
That is so wild.
So yeah, a massive battery absorbs the energy faster than a tiny one.
But I have to stop you there and push back on the practicality of this.
Okay, sure.
Because the sources mention how this energy is actually delivered, and it sounds, well, a bit alarming.
I know where you're going with this.
The prototype proved it could hold a charge, but it charges wirelessly via lasers.
Right.
Doesn't that mean, in a practical sense, we're going to be walking around a city or sitting in our living rooms with invisible lasers pointing at our pockets?
Yeah.
Like, how is that safe, let alone practical for everyday life?
I totally understand the hesitation. The word laser immediately brings up images of industrial cutting torches or, sci-fi weapons.
Yeah, exactly.
But in this context, we are talking about highly directed, low-intensity photonic energy transfer.
Okay, that sounds like a very fancy way of saying a laser beam that hopefully doesn't burn me.
Fair enough. Think of it more like the infrared beam your television remote uses, but infinitely more precise and capable of carrying actual energy.
Okay, I can picture that.
The systems being developed for this rely on strict line-of-sight targeting.
Yeah.
So, if the beam is broken by anything...
Like someone walking past it.
Exactly. A person walking by, a pet, even a heavy cloud of dust, the transmitter instantly shuts off before the beam even finishes crossing the room.
Oh, wow. Instantly.
Yeah, it's not a continuous, dangerous ray. It's a smart optical handshake between the charger and the battery.
So it only fires when it has a perfectly clear, confirmed path.
Precisely. And the impact of this optical handshake on your daily life is going to be profound.
How so?
Imagine pulling your electric vehicle into a parking spot. A targeted photon beam aligns with your car's receiver, and in the time it takes you to unbuckle your seatbelt,
It's done.
you have a full charge.
That is insane.
Or consider your personal devices, your phone, your smartwatch, your headphones. They just stay in a continuous state of wireless charge while you sit at your desk.
You would never physically plug a device into a wall ever again.
Never.
That completely removes the massive power bottleneck we've been struggling with for a decade.
Yep.
But, of course, overcoming one physical limit just reveals the next one.
Always does.
We bypass the physical limits of power, and suddenly we have a massive, continuous data flow from all these next-generation devices.
Which is a problem.
Right, because instant power is completely useless if the network running it is constantly vulnerable to cyber attacks.
That is the exact natural progression of these technologies.
Right.
If quantum batteries solve the physical power problem, the quantum internet solves the physical security and data routing problem.
And the sources show this is rapidly moving out of the theoretical phase.
Very rapidly.
There was just a live quantum network tested across 3 locations in New York.
Right, saw that.
They transmitted unhackable quantum keys across 120 kilometers of standard optical fiber.
Yeah.
And that detail really stands out to me. They used the standard fiber optic cables already buried under the streets.
What's fascinating here is the underlying mechanism of why this data is unhackable. Let's look at how things work today. Right now, your banking data, your private messages, they are protected by traditional encryption, which is, at its core, just a very difficult math problem.
Right. It's a lock with a billion-digit combination.
Exactly. And given enough time, or a powerful enough computer, that math problem can eventually be solved.
Someone can crack it.
Yeah. Your data can be copied, intercepted, and decrypted without you ever knowing someone was even looking at it.
Which is terrifying.
But quantum encryption throws math out the window entirely. It relies on the fundamental laws of physics. It uses entangled particles.
So effectively, the data is encoded into the physical state of the light itself.
Yes, the data isn't just riding on the light. The state of the light is the data.
Wow.
Because of quantum entanglement, the mere act of a hacker trying to observe or intercept that data physically alters the light.
So the system knows.
The system instantly knows it's being tampered with because the physical state collapses. And the key is destroyed before the hacker can read anything.
That makes hacking a physical impossibility.
Literally impossible.
But, the knock on a quantum internet has always been the hardware, right?
Yes, very much so.
The sources mention a breakthrough from Kyoto University involving something called W states.
Ah, right. W states are a specific, incredibly fragile type of entanglement involving 3 particles.
Okay.
If you touch one, the other 2 react instantly.
Wow.
But for 25 years, scientists couldn't reliably detect these W states without just destroying them in the process.
Oh, that's frustrating.
But the Kyoto team finally invented a highly stable photonic circuit that can instantly detect these states.
Which means we can finally route data securely between multiple users at the same time instead of just a simple one-to-one connection.
Exactly. And that routing just got much easier hardware-wise, thanks to another massive breakthrough.
From the researchers in South Africa and the UK.
Yes. They found a way to program the light itself using topology.
The mathematics of shapes.
Right.
Let's break that down. Because reading about twisting light into a corkscrew sounds like abstract art, not network infrastructure.
I know it sounds weird. Up until now, to bounce quantum signals around corners or route them through a network, we needed incredibly expensive, highly fragile mirrors inside the hardware.
Okay.
What this team did is mathematically twist the phase of the light waves. By twisting the light into a corkscrew shape, the light can actually travel through standard fiber optics and bend around corners
Without scattering.
without scattering or losing its quantum state at all.
So we are removing the physical mirrors entirely just by changing the shape of the light.
It dramatically simplifies the hardware. We're laying the digital tracks for a completely new kind of internet that uses the existing fiber under our cities.
Speaking of testing networks, the sources also mentioned the Jupiter supercomputer recently.
Oh, right, yes.
It successfully simulated a 50-qubit quantum computer, which seems like a huge deal for developing this stuff.
Massive deal. Simulating 50 qubits on a supercomputer gives us basically a sandbox to test these quantum network theories before we even build the final hardware.
So what does this all mean for the listener? Are you and I actually going to have a quantum router in our living rooms in 5 to 10 years?
Good question.
Or is this unhackable internet realistically only going to be used by banks, governments, and huge data centers?
Well, in the short term, the first nodes will absolutely be financial institutions and national security infrastructure.
Makes sense.
But the fact that they are using topological light and standard optical fiber in New York shows the actual intent.
Right.
This tech is being designed to integrate into the grid you already use.
Wow.
Within a couple of decades, your home internet, which will likely be managing a fleet of autonomous devices, smart fabrics, continuous biometric health monitors, all of that will operate on a quantum network.
That's wild to think about.
Your privacy won't be a password anymore. It will be guaranteed by the laws of thermodynamics.
So we use quantum mechanics to bypass the limits of power on Earth, and we bypass the limits of data security on Earth.
Exactly.
Which brings us to a massive thematic pivot in our sources.
A fun one.
Because what happens when we take these unprecedented leaps in processing and power and we apply them to the most physically demanding, unforgiving environment possible?
Deep space.
Deep space.
Space is the ultimate stress test. Everything we develop on Earth eventually finds its truest, most extreme application out there.
And the hardware pushing the limits right now is just wild. We've got SpaceX preparing Starship V3, which is the tallest, most powerful rocket ever.
Huge deal.
And Blue Origin's Mk1 Endurance lander surviving those extreme tests.
The physical propulsion leaps are incredible right now.
Yeah, NASA just successfully tested a new electromagnetic thruster at the Jet Propulsion Lab.
Which is fascinating.
It completely ditches standard rocket fuel. Instead, it runs on lithium vapor and intense magnetic forces.
It uses the Lorentz force.
Okay, what is that?
So instead of relying on a chemical explosion to push a ship forward,
Which requires massive, heavy tanks of volatile fuel.
exactly, this thruster ionizes lithium vapor, turning it into a plasma. And then it uses a magnetic field to accelerate that plasma out the back at incredible speeds. It is wildly efficient.
Okay, so the engines are fundamentally changing. But here's where it gets really interesting, and honestly where I start getting a little nervous.
How come?
Because alongside this new engine, NASA has developed a new AI space chip.
Right.
It's a radiation-hardened processor with hundreds of times the performance of current tech. And the stated goal is to allow spacecraft to, quote, think for themselves.
Yes.
Now, I have to be the skeptic here.
Please do.
Giving an artificial intelligence independent control of a spaceship millions of miles away sounds exactly like a sci-fi cautionary tale.
It sounds like a movie that ends badly.
Exactly. I mean, I've seen AI mess up a basic grocery list. What happens if this AI hallucinates or encounters an anomaly in deep space that it just wasn't trained on?
The grocery list analogy makes sense for, terrestrial generative AI.
Right.
But we have to separate that from the reality of deep space travel.
Right.
This really raises an important question about the limits of human control. Think about the communication delay. When we send a probe to Mars, the delay can be up to 40 minutes round trip.
Right. If you are streaming a video on your laptop and it buffers for 5 seconds, you get annoyed.
Yep.
Imagine waiting 40 minutes just to know if your multi-billion-dollar spaceship is still in one piece.
And imagine that spacecraft is flying through a debris field. Or it's trying to autonomously land on the shifting, hazardous ice of Jupiter's moon, Europa.
That's terrifying.
If it detects a sudden danger, like a shifting ice block or a micrometeoroid, it cannot wait 40 minutes to ask mission control what to do.
Because it would be a cloud of debris before the message even reached our satellites.
Exactly. A spacecraft must be able to make split-second autonomous survival decisions.
Okay, I see.
This AI chip isn't a generative chatbot prone to hallucinating poetry, right? It's a highly advanced pattern recognition and physics engine.
Okay, that makes me feel slightly better. But what about the physical hardware in space? Because the sources emphasize that this chip is radiation hardened.
That is the most crucial part. Deep space is literally flooded with cosmic rays.
Right.
On Earth, our atmosphere protects us. But out there, a single high-energy cosmic ray can physically pass right through a silicon microchip,
Oh, wow.
and it can flip a binary 0 to a 1.
Just by physically hitting the chip.
Yes. On Earth, if you open too many browser tabs, your laptop might freeze and you just restart. No big deal.
Sure.
In space, if a cosmic ray flips a bit during a landing sequence, the engine fires at the wrong time, and the mission is entirely lost.
Oh, wow. That's game over.
Exactly. This new AI chip is built on an architecture that can physically withstand that radiation bombardment while continuously running real-time, complex survival algorithms.
So we have these ultra-fast spacecraft powered by lithium vapor and magnets.
Yep.
We have the onboard AI processing to let them survive the journey without us essentially holding the steering wheel.
We do.
But the obvious question is, well, where are we actually sending them?
That's the big one.
Because according to our sources, all this technology is pointing toward a very specific destination.
We are actively mapping the search for life.
NASA recently released a massive new map of the cosmos. It was compiled from 8 years of data from the TESS satellite.
TESS is incredible.
Yeah, they mapped out 6,000 new exoplanets. But they didn't just dump a list of 6,000 planets onto the internet and say, good luck.
Right.
They filtered that data to create a highly curated shortlist.
Out of those 6,000 worlds, they narrowed it down to 45 rocky exoplanets.
Just 45?
And what makes those 45 specific planets the holy grail for astronomers is that they sit perfectly within the habitable zones of their host stars.
The Goldilocks zone.
Exactly.
It's not just about the temperature being not too hot, not too cold. It's about the atmospheric pressure and surface conditions being just right to allow liquid water to actually pool on the surface.
Because where there is liquid water, there is the potential for biology. And this shortlist gives our most powerful instruments a target. You mentioned the James Webb Space Telescope earlier.
Yeah, the one that just made headlines for mapping 164,000 galaxies in the cosmic web.
That's the one. It is now turning its massive mirrors directly toward these 45 specific planets.
To look for biomarkers. I find the mechanics of this so cool. It's called transit spectroscopy, right?
Yes, transit spectroscopy.
Yeah.
When one of these 45 planets passes directly in front of its host star, the starlight filters through the planet's atmosphere before traveling across space to our telescope.
And different chemical gases in that atmosphere absorb different colors of light.
Precisely.
So we essentially look at the starlight that reaches us, see which colors are missing, and that tells us exactly what chemicals are wrapped around that planet.
It's like a barcode. If we see oxygen, methane, or even artificial pollutants, we have found a chemical fingerprint of life.
That gives me chills.
If we connect this to the bigger picture, you realize how drastically humanity's methodology has changed here.
Yeah.
For decades, we were engaged in passive searching. We were basically just staring at the sky with radio dishes, hoping to hear a random blip.
It's like staring at the surface of the ocean and just hoping a fish jumps right into your boat.
Exactly. But now, we are engaged in a highly targeted strategic hunt. We have the map.
We know where to look.
We have the exact coordinates of 45 rocky, habitable worlds. We have the instruments to analyze their atmospheres from light years away.
Wow.
We aren't just wondering if we are alone anymore. We have the addresses, and we're knocking on 45 specific doors.
It is truly incredible to look at the narrative arc of what we've unpacked today.
It really is.
We started with quantum batteries that bypass the physical limits of chemistry, charging instantly by using collective superposition.
Right.
That massive leap in power generation paved the way for bypassing the physical limits of data security,
The quantum internet.
creating unhackable quantum networks that route information by twisting light into corkscrews.
Which then provides the underlying technological confidence to bypass the limits of deep space.
Yes.
We are building AI processors that can survive cosmic radiation and think for themselves, mounted on ships powered by magnetic lithium plasma.
And finally, we have a map. a curated shortlist of 45 new potential homes for humanity to actually point those intelligent ships toward.
I think the most vital takeaway for the listener today is the timeline.
Right, because this isn't science fiction anymore.
No, these are not theoretical white papers predicting what might happen in the year 2100. The quantum battery prototype is sitting on a lab bench today.
Wow.
The 120-kilometer quantum network is currently live under the streets of New York.
Yeah.
The NASA AI space chip is actively running simulations. These are tools being utilized right now. They are going to fundamentally change the trajectory of your lifetime.
As you go about your day, I want to leave you with a final, slightly mind-bending concept to mull over.
Oh, I love these.
We spent time today talking about how quantum entanglement allows for an instantaneous connection between particles, completely regardless of the physical distance between them.
Right, Einstein's spooky action at a distance.
Exactly. If our autonomous AI spacecraft eventually reach one of those 45 habitable worlds in a neighboring star system,
Okay.
could we one day utilize those entangled quantum states to build an interstellar internet?
Oh, wow.
Imagine pulling out your phone, powered by a battery that charged in a single millisecond, and streaming a live, high-definition video feed from a colony on Earth 2.0 with absolutely zero lag,
Oh, 40-minute delays.
instant, unbreakable connection across the stars.
That is incredible.
It's a universe where time and distance simply stop being barriers. Keep that in mind next time you're waiting an hour for your phone to charge.
This has been Better Side of the World. And somewhere tonight, something good is still happening.